Hi everybody! Today we'll be discussing limits part 2. So in the previous video we discussed about the idea of the limit. So what is the limit? Well, we could draw a graph f of x, which is x squared in this case. And so we can draw our graph like this. I can draw a better one. Like this. And then we can draw our f of x, which we know is a quadratic like this. And this is our x-axis, and this is our y-axis. So what if I were to ask you, what is the limit as x approaches 3 of this f of x graph? So, well, we can go to 3 on the x-axis, let's just say it's there, and this plots in the right here, it plots to go right there. And when we look on where it is on the y-axis, we see that it's just 9. And this makes sense, right? 3 squared is equal to 9. So it's supposed to be 9 on the y-axis. So what would be the limit? Well, we could approach the x value 3 from both sides on the x-axis, and then locate their corresponding y value on the f of x graph. And we can see that these y values approach 9. Right? So that means that our limit is just 9. So the method we just used here, we just took it from a graphical perspective, but we could do this algebraically pretty much the same way and much easier, much faster than just having to graph it. So limit as x approaches 3 of x squared is just equal to, what is it? We just have to plug in that 3 because we know x squared is continuous. We discussed that last time, because if it's discontinuous, then we can't always just rely upon directly substituting it. So it would just be 3 squared, which equals 9. So this first method, we can call it direct substitution, or DS for short. It doesn't matter how you want to pronounce it or say it. I'll just call it DS. But there are also accounts or times when directly substituting things doesn't work. And for example, we'll be solving this limit, which I talked about in the previous video at the end. So it's the limit as x approaches negative 2 of x squared plus 4x plus 4 over x squared plus 5x plus 6. And how would we be able to solve this equation? How would we be able to solve this limit? Well, we could start by directly substituting it. And what do we get? I'll just do this in red. So we get negative 2 squared, which is just 4. And then plus 4 times negative 2, which is 8, minus 8. And then we do plus 4. And this is equals 0 on our numerator. And now we'll just do our denominator. So negative 2 squared is again 4. And then 5 times negative 2 is equal to negative 10. And then we'll add a 6. And this again gives us 0. So we get our limit is 0 over 0, which does not make sense at all. And why is that so? We cannot divide by 0. So what can we do here? Well, yeah, you guessed it. We can factor it because these are both quadratic equations. And one thing we always remember about when we see quadratics is that we can factor. So our second method of approach is factoring. So I'll just pull this down a little bit. So I'll just rewrite the limit. So it's limit as x approaches negative 2 of x squared plus 4x plus 4 over x squared plus 5x plus 6. And what do we get here? Well, we know that x squared plus 4x plus 4, I'll write that down back here, is equal to x plus 2 squared. And that this function, x squared plus 5x plus 6 is equal to x plus 2 times x plus 3. And now we can rewrite this thing, and I'll just expand this to be x plus 2 times x plus 2 over x plus 2 times x plus 3. And now we can cancel out these common terms from the numerator and the denominator, the x plus 2 over x plus 2. And so we just get x plus 2 over x plus 3. The limit as x approaches negative 2 of x plus 2 over x plus 3. And now I'll just erase this part here. And so we have more space here. So we get this is equal to the limit as x approaches negative 2 of x plus 2 over x plus 3. And now we can go back to our regular method of directly substituting it in, and we get 0 over 1, which is equal to 0. So one thing we have to clarify is that when we solved this, we started with our initial function, let's call that f of x, equals x squared plus 4x plus 4 over x squared plus 5x plus 6. And then when we factored it, we got to a new function, g of x. g of x is equal to x plus 2 over x plus 3. And you might say, wait a minute, why do we need to define another function for the same thing? We just had to simplify it, and we got the same thing. So why do we have to define it as g of x and not as f of x? Well, as you can see here, we have our denominators, and when we have denominators, where the denominator can at some point be equal to 0, we have asymptotes, or places where the denominator cannot be equal to 0, where the denominator cannot have a certain value. So here we have that x squared plus 5x plus 6, we know that that is equal to x plus 2 and x plus times x plus 3. So that means x, whenever x is equal to 0 here, I mean, when this thing is ever 0, this function is not defined at that point. So that means that we cannot have x is equal to negative 2, nor x is equal to negative 3. And that is why we were not able to find the limit as x approaches negative 2 of this whole thing. So, but here we have our denominator is x plus 3. So that means x cannot be equal to negative 3. And so here we see a change. In the first equation, our initial equation, we could not have negative 2 or negative 3 as x. But here we take out that negative 2. So we remove a discontinuity in order to solve our limit. And I'll just show you guys the graph of this equation before we move on. So let me just pull it out here. And I guess you can see it here. So here we have our this is where we're trying to find our limit at. We're trying to find the limit at, ooh, why is it not? Okay, yeah, here we go. We're trying to find the limit as x equals negative 2, and we can see here that it approaches 0 from both sides. So our limit was correctly approaching 0. So the answer was 0 indeed. And if we were to go closer and click on this spot, we would see that this is undefined. We do not have, it's an open dot here. And here we could see that, remember, we had our x cannot be negative 3, and x cannot be negative 3 in the modified equation as well. And that's because we have an infinite discontinuity at x equals negative 3. But we're not looking at x equals negative 3, we're looking at x for the limit as x approached negative 2, so we don't need to worry about that right now. So that's one method of solving the limit for different equations, but there are still other types of limits which we can still not be able to solve. So let's address some of those. And even after we address this one, there will be more, but we will not cover that in this video. We will be covering that in future videos. Okay, so what we have to solve here is the limit x approaches 3 of the function square root of x plus 1 minus 2 over x minus 3. how would we solve this? Well, we could do our direct substitution, but then we get this is equal to 2 minus 2 over 3 minus 3, which is equal to 0 over 0. Doesn't work. Can we do factoring? Well, no. This is just already factored. But there is a way we could factor it, but we don't need to really worry about that because there's a much easier and more explicit way of addressing this. And this is our third method of approach, rationalization. And we'll just abbreviate that to RATL dot. And what this is if we have a square root in our function, we just multiply it by its rational conjugate. So the conjugate of this thing here would just be that. We just have to switch the sign. And how would we approach this? How would we use that rational conjugate? Well, we'll find out. We just have to multiply this by 1. And what I mean by 1 in this case is the conjugate over itself. So we have the conjugate over itself here. And then we know that this is a difference of squares, so we just get x plus 1 minus 4, which is equal to x minus 3 on the top. And then we have this thing times the conjugate. And here we can see that we could just immediately cancel out the x minus 3 over x minus 3. And so we're just left with the limit as x approaches 3 of 1 over the limit 1 over x, the square root of x plus 1 plus 2. And we could just substitute that in. And here we just get, this is 3 plus 1, 4, square root of 4 is 2, plus 2 is equal to 4. So we get that this is equal to the 1 over 4. I don't have a graph of this, but yeah, you could graph it on Desmos or wherever you want. And you would see that it indeed approaches 1/4. And again here, this initial function is not equal to the modified function because here we have that x cannot equal 3, right? But here we have x can equal 3. So there is definitely a change between these two graphs, or these two functions. But we can't really see that when we graph it. It looks pretty much the same. So we'll just recap this here. So we learned about two new techniques. The first one we learned was factoring. When we see any quadratics, we can just factor them, and we would be able to do it, but we need to know that the initial function for anything when we modify it is not equal to the modified function. And you would have to specify that when you do, like, when you solve problems in calculus in school, so that you would get full points. And the other method we learned was rationalization, multiplying it by the conjugate to get our answer. So I'll just give you guys a few problems, and you can solve them if you want, and put your answers in the chat in the comments section below. And I'll be solving it in another video, which I'll post shortly after this. So our problem for factoring is, our challenge problem for factoring is the limit as x approaches -2 of 2x squared plus 10x plus 12 over x squared plus 3x plus 2. And you can pause the video and like write it down and start solving it. And I'll just be writing the rationalization problem. You can always rewind the video if you want to see it again. And for rationalization, the limit as x approaches 25 of 5 minus the square root of x over 25 minus x. So if you have the answer to any of these, you can just put them in the comment section below, and I will be posting the solutions to them in the next video, which I'll be posting shortly. So thank you all for watching. I hope you guys understood the concepts. If you have any questions, you can always reach out to me in the comments section below, and I'll try to answer them as quickly as possible. Thank you for watching, and have a nice day.